Our next topic is Fourier series, but before we get to Fourier series, we will cover some needed topics. First one is inner product space or inner product. We define inner product of two functions. F1 and F2. And interval AB as, so it's simply an integral actually, a to b f1 of x f2 of x dx. So that's the definition of inner product of f1 and f2. So this is the way to write the inner product. This is the symbol for writing inner product. So if the question says find the inner product of two given functions, for example, let's take question is our example, find inner product of x and x square on minus 1 1. So it means our answer would be, let's say if we call f1 equals x and f2 equals x square, that means f1 f2 inner product is minus 1 to 1. Our interval is minus 1 to 1. f1 of x f2 of x dx. That would be minus 1 to 1 x square dx. That means minus 1 to 1 x cubed dx, or in other words 1 by 4 x4 minus 1 to 1, and that is 1 by 4 1 minus 1, answer is 0. That is alright to have an answer 0. So inner product of two functions is basically just an integral. We multiply the two functions together and take the integral over the given interval. So it's a very simple concept. Sometimes it's 0, sometimes it is not 0, and we have a special name for the situation when it is 0. We say, and it is called orthogonal functions. Two functions f1 and f2 are called orthogonal if their inner product equals 0 on an interval AB. The mention of interval is very important here, because same two functions might not be orthogonal on a different interval. I'll give you a quick example. So we just saw an example up here. So we saw that the inner product of x and x square on minus 1 to 1 is 0. So I can say from the example above, I can say that the functions x and x square are orthogonal on minus 1 to 1, because we have already seen that when we take inner product of x and x square on minus 1 1, it is equal to 0. We have already seen that inner product of x and x square is 0 on minus 1 to 1. But what if I take the same two functions? Let's say if I take x and x square on 0 to 1. So what will happen if I take 0 to 1? Same functions but a different interval. So if I integrate 0 to 1 x square dx, well, that's the same integral actually. I can write it directly. So x cubed dx, that is 1 by 4 x for 0 to 1, and it is equal to 1 by 4, not equal to 0. It means the same set of functions x and x square are not orthogonal on 0 to 1. So this is an important point to note in the definition of orthogonality, that two functions f1 and f2 are called orthogonal if their inner product is 0 on an interval AB. So the mention of interval is very important in the definition, although the wording should be a little bit improved. Are called orthogonal we shall write it like that's better. So two functions f1 and f2 are called orthogonal on an interval AB if their inner product is 0 on AB. So that makes more stress on the interval importance. Right. Let's do a quick example, another quick example. So the question is index size 12.1 and question number 4. Check whether given functions are orthogonal or not, and the functions are f of x equals cosine x, g of x equals sine square x, and the interval given is 0 to pi. Alright, how do we check? So first, of course, we take any product of the two functions on the interval 0 to pi cos x sine square x dx. That's a very simple integral. We put sine x equals t, and that is cos x dx equals dt, and that would be integral cos x sine square x dx will become u square du, that gives 1 by 3 u cube. Okay, so our integral f to g becomes 1 by 3 sine of x whole cube, and the limit is 0 to pi. So that gives 1 by 3 sine cube of pi minus sine cube of 0. And the answer is clearly 0. Note that sine of x whole cube can be written as sine cube of x. Okay? That is, and the rest you can use your calculator. Sine of pi is 0, sine of 0 is 0, and that gives answer 0. So this implies that f and g stop.